In this subsection on modeling, we shall see how we leave from the binary classification problem to the multi-class problem. So initially we had seen this with the binary classification problem. So supposing we had inputs x1, x2, and this 1 as a bias, we have the sigmoid of theta 0 x 0, which in this case is 1. So it's the sigmoid of theta 0 plus theta 1 x1 plus theta 2 x2, which equals this. Now, with multi-class classification, we have something which looks like this, but with the difference that we have two classes or two possibilities in this case. So hence the name multi-class classification. In multi-class classification, we have these parameters. That is, if we have, say, these 3 inputs or 2 inputs and 1 bias, say forming these 3 inputs and then 2 outputs, we then have 3 times 2 parameters. So we have 6 parameters, because from this input going to the output, we have 2 possibilities. Either we move this way or we move down to this next output. Hence we have theta 0, 0 and theta 0, 1 instead of just theta 0. Then for this next, we have theta 1, 0 and theta 1, 1. This is a typo. So we have theta 0, 0 and theta 1, 1 instead of just theta 1. Now with this, we have theta 2, 0 and theta 2, 1 instead of just theta 2. So we have theta, the input position, output position. So in this case, where our output is 0, we have 0 as output, and the input is 1, we have 1 as an input. Then there is some modification at the level of the output. Instead of the sigmoid function, which we saw previously, we have the softmax. How does the softmax function work? The softmax of theta 0, 0 x 0 plus theta 1, 0 x1 plus theta 2, 0 x2. Notice that the second term is always with 0 because we had the 0th output. So we have this 0 and then this 1. So this is the 0th output and then this is the first output. So we have theta, we have this. Now the softmax of this is the exponential of this value, which is this, divided by the exponential of this value plus the exponential of this other value. Now doing this will ensure that the sum of the probabilities or the sum of the outputs will always be equal to 1. Recall that with the binary classification problem, we had either, or we're always striving to get either a 0 or a 1. So generally our input ranges from 0 to 1, and generally we say if our output is from 0.5 and above, we consider it as 1, and output from 0.5 below, we consider it as 0. In this case, where we have several classes, we want the sum of all the outputs to be 1. So we have this, if we take this plus this, is going to give you 1. So in this case, below, like in this other output, we have theta 0, 1. We have, notice this is 1, this is 1, this is 1, because this is the first output, or the output of index 1. So we have the softmax is equals e to the power of, or the exponential of this we get, which is this, divided by the exponential of this plus the exponential of this. So what we're doing is, for each and every output, we have the exponential of each output divided by the sum of the exponentials of all the different outputs. So in this case, for example, if we have the softmax of this vector, we have, so in this case we have this 3 class outputs. We have the softmax of 1, 3, 2. It's going to give us e to the power of 1 divided by e to the power of 1 plus e to the power of 2 plus e to the power of 3, or plus e to the power of 3 plus e to the power of 2. And then for the next, we have e to the power of 3, which is this case, e to the power of 3 divided by e to the power of 1 plus e to the power of 3 plus e to the power of 2. and then this e to the power of 2 divided by e to the power of 1 plus e to the power of 3 plus e to the power of 2, and which gives us this. If you add this up, you should get 1. So if we have an output like this, it tells us that our class is this third class. Now let's look at another example where we have 3 different classes. So we have this and then we have this. So we see how in this case we have 3 inputs, 3 outputs, so we have 9 different parameters, as when we add this input we have 3 different possibilities. And so since we have 3 possibilities, here 3 gives us 3 times 3, hence 9 different parameters. For each of them, like in this case, we have the softmax of this is equals the exponential of this divided by what we have here plus the exponential of this plus the exponential of this, which gives us this value. And then for this next one, we have its value, that's the exponential of theta 01 x0 plus theta 11 x1 plus theta 21 x2 divided by the sum of the exponentials of these different outputs. So we repeat this up to this third class. So it's for this reason that sometimes we call this problem the softmax classification. Now coming back to our task, the way we could look at this is this. We had the 16 different inputs. So in this case, we're going to have x1, x2, right up to x16. Then with this 1 as the bias. So we have 16 different inputs, and then we have 26 different outputs, giving us 17 times 26 parameters. So we see that we've left from this logistic regression problem where we had just 3 parameters to a softmax classification problem where we have 16 or 17 times 26 parameters.